Now we'll start off with the first session. Let me introduce you the speaker for the first session. And it is my privilege to introduce our distinguished speaker for this session, Dr. Mohammad Yusuf Khan, currently serving as the principal of the Polytechnic at Maulana Azad National Urdu University, Hyderabad. Dr. Khan holds a PhD in Electronics and Communication Engineering, specializing in wireless communication, and has over 2 decades of rich academic and administrative experience. His illustrious career includes leadership roles such as member of ATAL Incubation Center of Niti Aayog and chairperson for AICTE-CII. An accomplished researcher, Dr. Khan has numerous publications to his credit in areas like signal processing, artificial intelligence, and wireless networks. His notable achievements include representing India in international programs such as Study of United States Institutes and the United Kingdom India Educational Research Initiative. Dr. Khan's dedication to innovation is exemplified by his patented work in fuel tracking systems. He is also a member of esteemed professional bodies like IEEE, ISTE, and the Institution of Engineers. We are honored to have such a dynamic and accomplished academic leader with us today. Thank you, Dr. Khan, for joining us today and for gracing this program with your presence. We are all eager to hear your insights and learn from your extensive expertise in sustainable energy management and environmental protection. Without further ado, I would like to invite you, Dr. Mohammad Yusuf Khan, sir, to kindly take over the session. Thank you, sir.
Thank you, Haja Fatima Madam, Assistant Professor, Maulana Azad National University and Polytechnic Hyderabad. We'll start with this session. Okay, let me start with the session. So today's first session topic is Introduction to Sustainable Energy Management. The contents of my presentation are, we'll start with the introduction. What is energy management, sustainable? How do you do, what is the difference between energy management and sustainable energy? The key principles involved in sustainable energy, types of sustainable energy sources, and benefits of sustainable energy management, challenges in sustainable energy management, the role of education institutions in sustainable energy management development, and of course the future prospects of sustainable energy management. And we'll take some of the case studies of India's sustainable energy management. So let us start with, first we'll start with we'll understand what is energy management. So whatever might be a process, a systematic process, which is to be controlled, which is to be monitored, controlled, and optimized in order to minimize the cost and environmental impact. For example, let us take an example of an industry or a factory or an organization where we have a CFL, that is compact electronic fluorescent lamps. If you go for that, the efficiency will be very less, the cost is high, and if you replace these CFL bulbs with light emitting diodes, the efficiency, energy efficiency, that is with the minimum input, maximum brightness you'll get, and the span of LED is 50,000 hours when compared to CFL, that is compact electronic fluorescent lamp, whereas the span of CFL lamps or bulbs are 8,000 up to 8,000 to 15,000 hours only. And the efficiency of CFL lamps are less when compared to LED bulbs and LED lamps. Therefore, like this, we can have a systematic control, monitor, and optimization of the energy sources, energy which is available in a particular organization or institution. So that is an example of energy management. Definitely, when you go for the energy management, we needs to understand the goals. For example, the first and foremost thing is there should be reduce energy consumption, efficiency. Yeah, efficiency have to be improved, and the cost should be low. Now, compared to LED CFL, initial cost of CFL bulbs are low when compared to LED, but when you go for the long term, the cost of LED will be, you can say, a reasonable cost, and minimize environmental impact. Definitely, when you consider LED, there is a very less environmental impact, or you can say zero environmental impact. Whereas if you go for CFL, in CFL we have the tube wherein we have mercury. When it is broken, the mercury, it will be hazardous and it will be having environmental impact. So these are the main factors to be considered when you are going for the energy management. And whenever you are going for the energy management, you have to consider the minimum cost, that is the economic sustainability and environmental impact. Now, these are the leading countries which are excelling in energy efficiency. We have Japan, we have Germany, advanced energy audits, South Korea, where we have smart energy grids. Now, when we have understood the term energy management, let us take what do you mean by sustainable. So whatever the process is there in energy management, that is monitoring, controlling, and optimization. Same things are there, but here in sustainable, the systematic procedure, the procedure will be for the long time, for long time durability. Whatever the energy management is there, that management should last for longer time. That is known as sustainable. When you consider for sustainable, there are three important factors in sustainability. That is, we have to consider the environmental sustainability, wherein there should be no environmental degradation or impact on the environment. Second, that is the economic sustainability. That is the cost effectiveness. Whenever you go for the long-term energy management, the cost, there should be minimum cost effective. Then we have social sustainability. The standard of living standard should be improved, and it should be of social equity and well-being for all members of the society. So these are the three important factors for a systematic process to go for a long-term process, for a durable process. That is known as sustainable. Now, sustainable energy, in fact, it plays a key role in decarbonizing. We'll see in the upcoming next slides, decarbonizing, what is meant by decarbonizing, what is meant by greenhouse gas emission. So sustainability reduces the dependence on fossil fuels. So nowadays we are going for the renewable energy. Therefore, dependence on fossil fuels is getting reduced, and it also creates millions of jobs around the world. The sustainable energy is the future, wherein many jobs are to be generated. A future for environmental responsibility, to improve our quality of life, and for its contribution to economy, among other reasons. That sustainable energy management involves, just to have given the example of energy management, now we have come to the term sustainable energy management, which involves managing the energy. If you take the electricity, the production, the distribution, and the consumption, it has to be managed, and it should be through a long term, and without affecting, or with minimum effect on environment, and meeting the energy demands. That is sustainable energy management. The core focus areas are whenever you go for sustainable energy management, we think about renewable energy sources. Renewable means reusable energy sources, energy efficiency technologies, wherein low input, output will be high. I have given the example of LED, which requires low input supply and the brightness, the output is very high. Reduce dependency on fossil fuels. Definitely, naturally, when you go for the renewable energy sources, dependency on fossil fuels will be less. And in fact, we have sustainable technologies. Here, the key goals are long-term energy security, environmental sustainability, economic affordability. The countries which are leading in sustainable energy management is Sweden, wherein almost 60% of energy they are extracting from renewable energy sources. Then comes the Denmark. They are using extensive wind energy, known as hydropower energy adoption. Portugal, 100% renewable energy on certain days. Now, the key principles of certain sustainable energy management. Key principles, these are the key principles. Energy efficiency, just now I've said, maximum output while minimizing the energy consumption. Use of renewable resources. Renewable resources are, renewable means which can reoccur, which can be regrown, which can be reutilized. We have that are solar, wind, hydro, and biomass, then ocean winds, you can say, instead of fossil fuels. Environmental responsibility means without polluting the environment. It depends upon, again, the solar, wind, hydro, and biomass instead of fossil fuels. Economic viability, cost effective. Yeah, it should be cost effective. It should not be cost escalating. It should be cost effective. Innovation technology, because of the digitization of grids, which are known as smart grids or microgrids, offset grids, we can go for the IoT-based monitoring system or AI-based monitoring systems. Then we have every country, each country has its own government regulations for cleaner and energy adoption. Policies are there. The policy support should be there. The countries which are excelling in the key principles of sustainable energy management are Germany, energy efficiency and policies. They have a very rigid, strong policies. Government policies are there for energy conservation, renewable energy. Netherlands, wind energy leadership, they are known as. China, massive solar and wind power projects. The types of sustainable energy sources. There can be many types, but let's see the main important ones. We have wind energy. The energy or electricity can be extracted, can be harnessed from wind, or in solar, the energy can be extracted from the sunlight. In geothermal, the energy is extracted from the inner layers of earth. And in biomass, you can see the energy is extracted from the organic matter of plants and animals. Then we can extract the energy or electricity, you can say, from flowing water. Let's take one by one, and I'll give a small, brief introduction of, you can see the small videos of each one. Let us take the first one, solar energy. It's one of the type of renewable energy sources wherein we utilize or harness sunlight using photovoltaic panels. Solar energy is utilized from the sunlight to generate electricity. Okay, so because of this solar energy, we can promote the environmental sustainability. We can have solar energy can be recreated, regrown, reusable. Okay, let's see one small video. Let's understand this solar energy, renewable energy.
Sir, we are not getting any audio of this videos.
Audio. Okay. Audio. Now, is it audible?
No, sir. Just the video is getting played.
Audible?
No, sir.
Now it's audible?
No, sir.
It's audible, sir.
Okay. Thank you.
मेरे को audible है.
Sir, only you are audible. The video voice is not audible.
We can hear you, but not the video, sir.
आगे. आ रही बोला बस.
Audio नहीं आ रहा सर. Audio is not listening.
आवाज नहीं आ रही. Now.
The video is getting played, but audio we are not getting it out of it.
Balancing of supply and demand, allowing fluctuating energy meters. In this phase, high voltage step-up transformers are used to increase the voltage for transmitting power from long distances with the help of these towers. Some solar plants back. It is used to store excess electricity generated during periods of sunlight for later use when sunlight is unavailable. Batteries are safely power system. Once the electricity generated by solar panels is converted from direct current DC to alternating current AC by the inverter, any excess energy can be stored in the battery bank for later use. A solar panel consists of multiple layers designed to protect the panel, with solar cells being the primary components. Solar cells are composed of semiconductor materials such as silicon. When sunlight penetrates the solar panel, it generates electricity, typically in the form of direct current DC. Friends, if you want to gain the knowledge how does solar cell generate this DC current, comment below. I will back soon. Thank you. Let's grow up. Never stop learning.
Then we have wind energy. Here we are harnessing the wind using the wind turbines to generate the electricity and the power of wind to generate electricity. Here, this also reduces with the wind. It reduces the carbon emission and contribute to environmental sustainability, less impact on environment. Let's have one video for this also, wind energy. Let's understand this.
Electricity is very important to people. Use it to power our homes, cities, trains, and cars. One of the main ways we produce electricity is with the use of a generator. A generator is a device that converts mechanical kinetic energy into electrical energy. A wind turbine is a very large windmill that uses the kinetic energy of wind to spin its blades. The blades spin a generator that transforms the energy into electrical energy. Often, particularly in very windy places, many wind turbines are grouped together to form a wind farm. Wind farms can produce enough electricity to power whole cities. A big advantage of wind energy is that it is a clean and renewable energy source. It does not require the burning of fuels and does not produce harmful emissions into the air. There are some disadvantages of using wind energy. The large spinning blades on a wind turbine can kill or harm flying animals like birds or bats. They can produce loud sounds that can disturb natural environments and be annoying to people. And if damaged, wind turbines can be expensive to repair.
Then we have, we can generate the power from the flowing water. We have the dams, hydropower dams, wherein the energy is harnessed from the flowing water to generate electricity. For this also, we have a small video.
Conversion of water into electricity. It is a considered renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. Mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Among energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dam reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
Then we have the fourth one that is known as biomass energy. Here, let us understand what is biomass first. Biomass refers to the organic remains of plants and animals. Here, the organic waste of the plants and animals can be directly burned into heat or generate the energy, or it can be converted into biofuels, like which are like, for example, like biogas, biodiesel, like that. And moreover, biomass energy generation, it's a renewable type, because whatever the remains of the animals and plants can be regrown, can be utilized. Therefore, it is a type of renewable energy source. Whereas if you take the fossil fuels, wherein fossil fuels are the remnants or the remains of the ancient plants and animals which are buried under the layers of earth for long, long, long years. Now that can be converted, that can be after the long duration, that can be transformed into the fossil fuels. And these fossil fuels are not a renewable energy, because it takes billions of years in order to again regrow the animals and plants like that. So biofuels are not renewable energy sources. Biomass are renewable energy sources, wherein we can directly convert into biofuels like biogas. But then the leading country which utilizes the biomass, for example, we have Brazil. In India also we use the gobar gas. And in Brazil we use the sugarcane biofuel industry. That is the leading country for the best example for the biomass energy generation. Coming to the fifth one, which is known as geothermal energy. Here we utilize or harness the heat from the Earth's crust. The crust of the Earth has developed the heat, and that heat is being utilized to generate the electricity. It's a type of renewable power, renewable energy produced. Now let's see one small video for geothermal energy also, how the energy is being harnessed.
Relaxed in a natural hot springs. You see the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? It comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust forms water that is seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust or plates meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity. Pretty straightforward. Another geothermal technology is called a flash steam power plant. The pump pushes hot fluid into a tank at the surface where it cools. As it cools, the fluid flashes or quickly turns into vapor. The vapor then drives a turbine and powers a generator. The binary cycle plant works differently. It uses two types of fluid. Hot fluid from under
Hello, sir. Please unmute the in charge email ID. Hello, excuse me, sir. Please unmute yourself. Yeah, okay, fine now.
Thank you. Now, is it audible now? Okay.
Yes,
Now,
yes, sir.
just
Good.
now we have seen geothermal energy, where energy is being extracted from the heat which is present in the crust of the earth, and that can be utilized for generating electricity. It has been greatly utilized in the countries like Iceland, extensive geothermal utilization. And the thing is, because of this geothermal energy, sustainable energy, it has minimal effect on the environment, which has some pollution effect on the environment. Now, coming to the sixth one, which is ocean energy. Here, we can extract the energy, we can utilize the energy from the high waves, tides, and thermal gradients. Now, this has been widely utilized in Australia. One of the university, which is known as Australian Federation University, recently they have approached in Hyderabad also. So they are calling for the research and development work and projects for projects in Australian Federation University, wherein ocean waves are being taken into consideration and energy is being utilized. That is one form of energy, ocean energy, from which electricity can be extracted. The leading country, of course, is South Korea, wherein tidal energy projects are being highly utilized. Now let's go to the other topic, which is the benefits of sustainable energy. I have told you in the very beginning. Always we have to remember the economical benefit, the environmental benefit, and the long-term benefit. We will see one by one. Environmental benefit. What do you mean by the environmental benefit from the sustainable energy management? The thing is, it should be it should reduce the pollution. If you take the greenhouse gas emission, wherein this is the effect, whereas the gases are released in the atmosphere, above the earth. These gases, what they do is they extract the heat from the sunlight, but these gases prevents the backflow of heat from the earth to the outer space, that is the out of the atmosphere. That means these gases prevent the backflow of the heat. So what happens because of that, the atmosphere of the earth surrounding the earth, the temperature increases, and due to that we have the global warming. Okay? So in order to not to affect or pollute the atmosphere, we have to take into consideration the environmental benefits. So if you go for the sustainable energy management, the first and the foremost important thing is we have to consider the environmental benefit. Means we have to reduce the pollution, the more polluting gases. If you take a greenhouse into consideration, the polluting gases, the most polluting gases, atmosphere polluting gases are, we have carbon dioxide, we have methane, we have nitrous oxide. These are the gases which have the capability to absorb the heat, but they prevent the backflow of heat outer the atmosphere. Okay, so environmental benefit is the foremost benefit. Then comes the economic benefit. Whenever the economic benefit comes into picture, the thing is it has to be cost effective, means low cost. It should be for the long term, but without affecting the cost. The cost should not be high. Social benefit. What do you mean by the social benefit? The social benefit means it should increase or enhance the standard of living. Standard of living. Once a living, it has to. Standard of living means it should be free from pollution, free from other polluting gases. Long-term benefits. Definitely, sustainable energy ensures long-term energy availability and reduces vulnerability to energy price fluctuations. As I've given the example of CFL and LED, wherein why we go for LED with light emitting diodes in industries, in companies, in order to go for the long-term benefits. So sustainable energy emphasizes more on these factors: environmental benefits, economic benefits, social benefit, and long-term benefits. The countries which are showcasing the above benefits are Spain, because of which there is a job hike in solar energy sector. If you take Canada, we have hydropower benefits. In Kenya, geothermal energy in rural areas. So that is the why we go for geothermal energy, because in Kenya lies in the zone wherein we can get the heat from the Earth's crust easily. Then definitely, whenever we have benefits, there are certain challenges in sustainable energy management. The challenges are, if you take, I'll once again take the example of LED and CFL. Initial cost of LED is high when compared to CFL. Similarly, installation of all these solar, if you take the wind, if you take the biomass, all the renewable energy sources or sustainable energy sources, the initial cost is expensive. But long term, if you go for the long term, the cost is effective, low cost. Similarly, you can go for the technological limitations. Whenever we go for the digital one, whenever I go for digital meters, there is always storage of data problem, and efficiency of renewable systems need improvement. Regularly, the efficiency has to be improved in order to maintain the effectiveness of the system. So there are certain technological limitations also. And moreover, because the lack of public awareness is there, the farmers, the urban area, local rural areas, people should be known, should be provided with the knowledge of sustainable energy benefits. The benefits initially, what they think is their land is being taken, but because of the sustainable energy, the pollution, the environment, everything will be maintained properly. So lack of knowledge and resistance to change. There are many people who are reluctant or hesitant to go for the change. They want to be with the conventional sources. They want to go on. They don't want to change themselves. So there are lack of hurdles in many countries, and it is not like that. The people are given the independence. You cannot have a sustainable energy project wherever you want. So the areas where we can go for the sustainable energy management, like tidal, wind power, solar, where we can absorb much of heat, the people has to be educated regarding this sustainable energy. Otherwise, it is very difficult. Then there are certain policy and regulatory barriers. Every country has their own government policies. There is not a collision of collision of policies, or joint policies or joint regulatory organizations in order to go for the sustainability. Because the future is for sustainable energy development, we have to go for the policy and regulatory barriers are also a limitation, or are also a challenge in many countries. Then, as I've told you, energy storage issues. The energy storage, if you take the olden days, we used to have the analog meters, but right now we have the digital energy meters. There are certain advantages of going for digital devices, digital storage meters, or wherein we can go for the data loggers, everything. But the thing is, the data storage is the issue. You have to store lakhs of gigabytes of data regularly, and it has to be reutilized, and that is the challenge also. Then the next topic is the role of educational institutions. What the educational institutions has to do in order to make these sustainable energy projects or renewable energy projects known to the people, the benefits of these projects, and the thing in order to avoid the global warming, in order to avoid utilizing fossil fuels, reliability on the fossil. Always we are reliable on the fossil fuels. So in order to have a change, in order to change the paradigm from non-renewable energy sources to renewable energy sources, the education has to be taken a leading role. Education has to take a leading role. In each country, we have the government education, the private educations. So the educations, what they have to do is, the institutions, what they have to do is they have to conduct the campaigns, workshops, seminars, FDPs, like the AICT is conducting this FDP. Because of this, the faculty will be knowing about the importance of sustainable energy, and because through faculty it can be conveyed, the message can be conveyed to the other industry people, other students, and it can be passed on to the other students and other knowledgeable persons, and it can be passed on to the rural areas also. So the educational institutions should take a leading role in order to conduct the awareness and education programs for the sustainable development energy management programs. Then, in fact, in order to have research and development, the sustainable energy has to be incorporated in our curriculum also. We have to introduce these future demanding topics to be included in our curriculum. If it is included, then research and development can be done. And the faculty has to definitely encourage the research scholars to take the sustainable energy technologies. There are lots of programs, lots of projects which can be taken, which can be utilized for sustainable energy. They can go for the solar, they can go for the wind. They can, if they are lying in the area where wind is very low, they can go for the solar projects. If these two conditions are not there, if they are near to the seashore, or they can go for the ocean. They can go for the wind also. They can go for the hydropower technologies and geothermal. If they are lying in the very hot zone, they can go for the geothermal energy projects. And definitely campus sustainability projects. I can give an example of my own campus, where I'm the principal and I'm the coordinator for this AICT. We have a biodiversity park. Recently, it has under the supervision of our Honorable Vice Chancellor, Professor Syed Ainul Hasan sir. We have started one biodiversity park. The area was a barren area. It was not utilized. And how we have converted, how our engineering section, led by Dr. Iqbal Khan, is the assistant professor in Civil Department of Polytechnic Hyderabad, how along with his team, engineering section team, has converted this barren land into a biodiversity park under the supervision of our Honorable Vice Chancellor. I'll give an example. I'll show in a video wherein how the sustainable projects can be implemented within the campus, within the institution, within the colleges. So let me show that. This biodiversity pond cum rainwater harvesting pond, it has been named recently. So just now I've shown a video of our university biodiversity park cum rainwater harvesting pond, which was taken up by our engineering section under the supervision of our Honorable Vice Chancellor, Sir, Professor Syed Ainul Hasan, Sir. The area just now you have seen, it is about 10,000 square meters, and we have a walkaway length of 500 meters surrounding the pound. The width of the walkaway is 20 feet. The depth of the pound is 5 meters, and we have planted 1,500 new plants, and we have utilized the surrounding grill, the fencing with our scrap material, and we have utilized that water. We have taken the water from the RO plants from the different hostels, 12 boys hostels and girls hostel. Approximately 40,000 liters per day, the RO water is taken into this pond, and we have not destroyed the rocks. The rocks are not disturbed. We have utilized those rocks, and we have 12 borewells of university. Borewells of university are surrounding the pole, and the capacity of pond to hold rainwater is about 11,400 cubic meters. That much of capacity it can sustain. Then we have many fruit plants also we have planted, like guava plants. We have 100 guava plants, 100 mango plants, 150 lemon plants, 150 new chiku plants, that is known as sapota plants, new papaya plants 15, and 200 new rose plants. So we have converted a 10,000 square meter land which was unutilized, which was not utilized, into a biodiversity park which has become the center of attraction in our university. That is an example of a sustainable project which comes under the institution. So Maulana Azad National University has taken a leading role converting the barren land into a, you can say, a biodiversity park. These are the global examples. We can take the Stanford University, wherein we have the whole campus is known as a renewable campus. And in India, we have IIT Madras, which is, as soon as you enter IIT Madras, you can see solar-powered campus. Now, coming to the future prospects in sustainability, research scholars, faculty can take up this one. We can have smart energy systems. As soon as there are many participants which are from electrical background, you know the difference between the grid and smart grid. One-way communication, two-way communication, and smart grid, we utilize the data loggers, we utilize the digital devices. And if you take the microgrids, we go for the minor scale, small scale area. We can utilize the microprocessor-based distribution system, whereas if you go for the local distributors, are there for in smart grids. So smart energy systems are being utilized with the help of the use of artificial intelligence and IoT. Okay, then these areas that also can be explored. Then we have the storage problem. In order to overcome the storage problem, data storage problem, we go for the advanced energy storage solutions, innovations in battery technologies. Recently, we have seen the transformation in electric vehicles and electric cars and vehicles. So there is a transformation. There is a large storage of data can be used for a good battery technologies. Then decentralization energy sources. Earlier, if you take the electrical grids, there was no decentralization of energy solution. But if you take the microgrids, if you take an off-grid, we have decentralization of energy system. Then increased policy support. Now, many countries, they are joining hands in order to go for a strong framework, joint framework, and government also stressing upon putting lots of interest on sustainable energy projects. We can see in the case studies how Indian government has taken sustainability projects, mainly in solar, in wind, and other areas. Global collaboration. Recently, in the Paris Agreement, many initiatives have been taken in order to go for the policy for sustainable development. And UK also, they have started sustainable development goals, wherein It has started in 2019. Now, because of this SDG goals, there are many workshops, seminars going throughout the globe in order to encourage for sustainable development projects. Now, we'll take some of the case studies of India's sustainable energy management. India is also leading in sustainable energy management. Okay, so first we go for the first one, that is, you can see the solar park which has been taken up by Karnataka Pavagada, Karnataka government, one of the largest solar parks in the world with a capacity of 2015 megawatts. It's a big one, huge one, largest solar park which has been taken by the Karnataka government. The key features are it is spread across 13,000 acres. Public-private partnership model involves leasing land from farmers. Very difficult task, taking leasing land from the farmers, ensuring steady income for the locals. Then the main outcome, the impact of this solar park is, because of that solar park, solar energy, the energy which is the heat which is being absorbed from the sunlight, the carbon emission has significantly reduced. Because of the carbon emission, we have the greenhouse emission effect. Okay, so because of the solar power, solar energy, solar parks, this has been greatly significantly reduced in Karnataka. Provides clean energy to millions of houses. And the key takeaway of this solar park at Pavagada, Karnataka is successful large-scale solar infrastructure with community involvement. Then the second one is the Gujarat Solar Power Initiative. Gujarat is the first state to launch a dedicated solar policy in 2009. Key features: Charanka Solar Park, 600 megawatts capacity, rooftop solar initiatives across cities. The output, the impact for this is it promotes widespread adoption of solar power, created employment opportunities. The key takeaway of this Gujarat Solar Power Initiative is effective policy implementation drives large-scale solar adoption. Then, and moreover, the government of Gujarat is also encouraging, motivating people to go for the rooftop solar projects, rooftop solar panels, which can be utilized for the utilization for hot water and for the kitchen and for the other purposes. Government is encouraging and giving the subsidized rates for the solar panels. Then we have the third one, Cochin International Airport. This is the first airport of India where world's first fully solar powered airport. We have a solar powered airport. Entirely it is by solar energy. The airport is being powered by the solar energy. Key features are 50,000 solar panels installed across 45 acres, and the airport solar power generates 40 megawatts of power, and the output is it saves 300,000 tons of carbon emissions annually. And it also reduces dependence on traditional energy sources using the fossil fuels, the conventional methods. Okay, so 300 tons of carbon emission is being saved. The key takeaway of this Cochin International Airport is renewable energy integration in infrastructure can lead to carbon neutral operations. Then fourth one, we have Delhi Metro. I think many of you have seen that Delhi Metro is being energy efficient and renewable integration. The Delhi Metro Rail Corporation integrates solar energy and energy efficiency measures. The key features is rooftop solar panels on metro stations, energy efficient regenerating braking systems. The impact is 60% of energy requirements met by renewable sources. Significant reduction in carbon emission. The key takeaway of Delhi Metro project, Rail Corporation project is urban transport can play a critical role in sustainable energy management. Then we have a national electric mobility mission plan launched to promote electric mobility and reduce oil dependency. Key features: incentives for electric vehicles. Now you can see the government of Telangana has going to start 10,000 electric buses. Likewise, many states has gone for the transformation from conventional fuel vehicles to diesel or petrol vehicles to electric vehicles, because of which there is a great reduction of carbon emission and through faster adoption and manufacturing of electric vehicles, charging infrastructure. The output, the impact is increased adoption of electric vehicles, reduction in urban pollution levels. The key takeaway of National Electric Mobility Mission Plan is policy-backed initiatives can accelerate sustainable transport solutions. Next one is waste to energy plant, Delhi. From waste, from scrap, we are getting the energy. That's what the plant has. It is based in sustainability. Then we have environmental sustainability. Okay. So based on those sustainability, these projects are plants have been developed. The key takeaway of this waste to energy plant is integrating waste management with energy production, which will definitely address multiple urban challenges. Then next one is Ujala scheme, that is Unnat Jyoti by affordable LEDs for all. Just now, in the very beginning, I have told you about the benefits of using LEDs when compared to CFL. The overview of this project is nationwide initiative to replace traditional bulbs with energy efficient LEDs. In our university also, most of the CFL bulbs tubes are being replaced by LEDs, and their duration, their brightness, their output, their span, it's much, and they are more efficient when compared to CFL. The key features are distributed 360 million LED bulbs, and this data has been taken. It's the last year data. 360 million LED bulbs have been distributed by the. It is the initiative of the Government of India which has been taken. Okay, and significant reduction in energy demand. The output is annual savings of over 47 billion kilowatts. Less energy, it takes less energy and more output. There is less input and more brightness. And I have also told you that the impact on environment is almost zero when you go for the LED. Whereas if you go for CFL, the impact on environment is hazardous because the chances of mercury emission. And naturally, reduction of over 38 million tons of carbon emission annually. Because of that, it has reduced the carbon emission. Just now I've said the greenhouse gas emission, out of which the carbon dioxide, nitrous oxide, and these are the methane. These are the gases which are known as major greenhouse gases, which prevent the backflow of heat from the Earth's atmosphere into the space, which causes the global warming. Because of the global warming, you have seen lots of changes in the global seasons and global. We have the unusual snow falling in many areas, and there are we have environmental changes, many environmental changes in many areas. So the key feature of this Ujala scheme is affordable, accessible technology can drive large-scale energy efficiency. The last one is International Solar Alliance. It is the joint alliance founded by India and France to promote. That's what this is the very good example, wonderful example where countries are collaborating and going for the solar energy, that is sustainable energy. Jointly, they are going for solar energy. And the key features are collaboration among 121 solar resource rich countries. Focus on technology sharing, finance, and capacity building. Its impact is output is mobilized significant investment for solar projects, enhanced global partnership in clean energy. The key takeaway of international solar alliance is international cooperation is essential for global sustainable energy goals. Then finally, what we have seen is what is energy. Let me brief once again what we have done. What we have seen in the introduction to sustainable energy management. I have started with the first one, that is energy management. Energy is nothing but a process, a systematic process of monitoring, controlling, and optimizing energy with the minimum effect on environment. Okay, if this energy management is for the long term, for long-term duration, that is known as sustainable energy. And sustainable energy management has three important things, that is environmental sustainability, social sustainability, and economic sustainability. Environmental sustainability means we have to prevent the environmental degradation. How to prevent the environmental degradation means polluting the environment. We have to prevent the pollution of the environment. Then we have economic sustainability means we should have cost-effective sustainability project. And the third one is social sustainability is the sustainability must be such that the standard of living should increase. One should feel comfortable or increase in standard of living. These are the three things which sustainable development energy management has: environmental sustainability, economic sustainability, and social sustainability. And we have seen the three principles of sustainable energy: energy efficiency, use of renewable energy sources, environmental energy sources, economic viability, innovation technology. Then there are many types of sustainable energy sources. I have touched 6 ones. First, I've gone for the solar energy and how the solar energy is being utilized. I've shown a YouTube video. Then wind energy, how to harness, how to get the energy from the wind. For that also I've shown a small video. These two, solar energy and wind energy, to the large extent, they contribute to environmental sustainability, to reduce the carbon emission. Then I've shown the hydropower, wherein the power can be harnessed. We can get the energy from the flowing water. For this also I've shown one small video where how the power is being extracted from the flowing water. From the you have seen that potential energy of water is being utilized. Then we have seen the biomass energy. I have given you the difference between the biomass and the biofuels. Biomass and the fossil fuels. Biomass is renewable energy, comes under renewable energy, whereas fossil fuels are not renewable energy sources, because in order to get the fossil fuels or remains of animals and plants, it takes millions of years in order to get those remnants. Therefore, fossil fuels are not renewable energy sources, whereas biomass, the organic waste of animals and plants, are sources of renewable energy. Then we have gone for the geothermal energy. The countries wherein the temperature is very high, we can go for the energy that can be extracted from the crust of the earth, the heat which is being taken into consideration. Because of that heat, we get the energy. Then we have seen the ocean energy. This energy is harnessed or extracted from the high tides, waves of the oceans, wherein I have given the example of Federation University, which encourages researchers to go for the projects which are based on ocean energy, extracting energy from waves, tides, and thermal gradients. Then finally, we have seen the benefits of sustainable energy management. Benefits means environmental sustainability. Benefit means the environment should be pollution free. Economic benefit means cost effective. Then we have seen social benefit means one should have a standard life. Then we have long-term benefits. Sustainable energy ensures long-term benefits. In fact, the challenges are initial installation of these sustainable energy sources. We have technology limitations, public awareness challenges are there, policy and regulatory barriers are there, storage challenges are there. In order to overcome these challenges, we have gone to the role of educational institutions. Throughout the globe, we have institutions. Those institutions can take the leading step in order to encourage, in order to give knowledge to the farmers, to the people, in order to go for the sustainable energy rather than for relying on the fossil fuels, which is very dangerous. Then we have seen the future prospects. The research scholars, the faculties can go for the smart energy systems, advanced energy storage solutions, decentralized energy solutions, increased policy support, global collaboration. Then we have seen eight case studies of India's sustainable energy management. Okay. So finally, I conclude, sustainable energy is very important for greener and more resilient future, economically, environmentally, and socially. And definitely sustainable energy belongs to those, the future belongs to those who harness sustainable energy today. If you go for sustainable energy today, then definitely our future will be bright. Sustainable energy is not an option. It has become compulsory. It is necessity. It has become a necessity. If we avoid sustainable energy now, then we will be in trouble in future. So I thank one and all. Any question and answers? You can contact me on the given email ID, use_lect@yahoo.com. Website, our university website is banu.edu.in. So this is about the sustainable energy management.
Participants, if you have any queries, you can ask with the speaker now.
This is the first session. That this is an introduction to sustainable energy management. Later on, the sessions will be the advancements in sustainable energy management and environmental protection.
Thank you, sir.
Thank you. Thank you.
On behalf of the organizing committee and all the participants, I express my heartfelt gratitude to Dr. Mohammed Yusuf Khan, sir, for delivering such a thought-provoking and enlightening session on sustainable energy management. So your detailed insights into sustainable energy sources, key principles of energy management, and the challenges and opportunities in this field have been incredibly enriching. The practical case studies and your emphasis on the role of educational institutions in promoting sustainability has provided a clear roadmap for contributing to a greener future. We are truly grateful for the time and effort you dedicated to making this session a success. Thank you for sharing your expertise and inspiring us to be more proactive in our journey towards sustainability. Thank you once again, sir.